All right, so welcome to this fourth lecture of the week on staking. And so far we have basically been looking at how to set up a private testnet that we can use for testing. And then in the previous lecture we saw a staking smart contract. That's just a very simple smart contract that basically ensures that when we withdraw our rewards, then that a certain address that is kind of hard-coded in the smart contract gets at least half of what we actually withdraw. So in this lecture, we want to see how we can kind of deploy this script on our private testnet, and then see if actually it works as intended, and it actually ensures that half of these ADA go to that certain address when we try to claim the rewards. Okay, so the first step is that we actually built the script, the smart contract, which we haven't done yet. So for that, in this week 8 directory, we have this build script. And because we have seen in the contract, we had this, let me open it here, this address, which is a parameter that we need to provide when building it. Here we can see kind of we have this argument which takes an address here, converts it into the right type, and then passes it to the OpShin command. Okay, so let's try to run this. And so we need to already provide the address that we want to kind of use later during testing, and for that we will be using from this Cardano private testnet setup the address provided here, which is this payment2.address. Okay, so now, here make sure you have the poetry shell, which all the dependencies started up, and then we can run this build script from week 8, and we provide the address here, which should be the one. No, it's actually not. So let me copy this address and provide it here as a command line argument. And now I run the build, and then it says, okay, build artifacts have been put in this build directory here. So as in previous examples that we have seen throughout the program, we have this folder here, and it provides like the CBOR and also the Plutus and so on. So later our scripts will actually be using what's in this asset directory. So let me actually copy now the script that we have just received from our build process here and put it into this assets folder. And now we want to go to the actual testing and like deploying part of the process. So currently I'm not in this Docker container which we use for testing. So let me fire that up, and then we can actually try to deploy the contract. So we reload the window. Then we are asked again to open it in a container, which we do. Okay, and now we first need to again start the private testnet, which we do by going to the Cardano private testnet setup, and then run this automate script, and we wait for this to finish. Alright, so now it tells us network is ready to use. So I will open a separate terminal which we can use. And then the next step is to okay, let us first change directory into source week 8 scripts, and then let's just see if it's running as expected. Yes. And then our goal is to run this register and delegate script. And what this will do, let's quickly go through it, is it will basically compile the right stake address that has as the staking part our script. And it will then register this address and actually build and submit the transaction to delegate to a certain pool using this kind of new address as a staking credential. So what we'll do here, so also one of the arguments will be a UTXO that we can use as input. We will provide it in a second. And then, yeah, we just set up the right kind of Cardano node path that we get from this private testnet setup. And then this part is about putting together the address. So for the address, we need the payment part and the staking part. And this command builds the staking part, and not as maybe in the non smart contract case where it would be just like a SKH file. Here the stake addresses part is actually built from the script, right? So this is what we want to do here. And then in this part we kind of put together the address from the payment part, which is this payment1.vkey, and then for this from the stake part, which we just built here. And then when we later want to have this delegation transaction, we need several things, and those are like a registration certificate and a delegation certificate, and those we kind of obtain from these two commands. And then we just sign and submit the transaction. Okay, so let's try if this actually works. So as I said, we need like an input here. So let me just query the UTXO of user 1, and we see we have this one here. So then we try to register and delegate using this argument here. And we see it has been successful. So it tells us here what is kind of this staking part of the address. And then it puts together this address from the pub key and the staking part. And then it successfully submits the delegation transaction. So now we have actually delegated to a pool. By the way, the pool is one of the ones that we kind of fetched from this query stake pools. So let me just show this. Yeah, so it's just we have these three pools, and here when we create the delegation certificate used in this delegation transaction, we just took basically the first line of this output, which would be this pool. So now we have delegated to this pool. Okay, now after having delegated, so this is where kind of the nice thing about this private testnet comes in, because in the regular pre-prod or preview testnet, we would have to wait for 5 days until there's actually some rewards, and then we could only then test the actual withdrawal. But now these epochs pass much faster and we can already test it. So let's have a look at this withdrawal script. So what we do here, provided wallet transaction input and payout address. So we first query kind of the current reward balance, because this we will have to kind of provide it when building the transaction. So we need to make sure the reward amount is correct there. And yeah, this is done using this Cardano CLI query stake address info. So then this amount of rewards that we have accumulated up to that point will be the amount 1. And we put it into this withdrawal here. And note that as we have as a staking credential a script, we need to provide here this withdrawal script file, similar to as in the spending or minting case, we would also provide the script here in the transaction. And we also then provide the redeemer, which in this case we didn't make use of the redeemer, so we just use kind of this like empty redeemer that is provided here. And then, yeah, if we think back, what does our script do? It enforces that also half of the amount basically goes to another address, which is here will be this payout address. Yeah, so we just put as change address like the address of like the original user basically. So like everything else will go to him, and then some of it will go to this other address, which is exactly like here. We take half and then we add 1 just to avoid like rounding issues. And yeah, when we now test it, we will actually let's first like comment out this line so that actually nothing is paid to this address. And in this case, we expect our validator to run into an error and then for the transaction to fail. Okay, so let's try to withdraw. Okay, so now it failed because actually I forgot to provide the transaction input. So to provide the transaction input, so previously remember that we use this like we use this user1 script to see all the UTXOs of user1. Actually now there's no UTXO left, and the reason why that's the case is because during this register and delegate transaction, we build a transaction from this wallet, but then actually the output, they don't go back to this wallet, but they go back to this change address here, which was the address that is kind of composed of this payment part, but the staking part being the script credential. So now we shouldn't query like directly this address anymore, but we use this other script called query UTXOs user1 script, which takes the address where like the staking part is now with the script. And if we query this, so one script, then we see now there's like previously we had like 300,000 ADA and then a bit of it went into the transaction fee. So like this is the output from exactly this registration transaction. And now for the withdrawal, we can use this UTXO as the input. Okay, and we get a failure, and this is exactly what we expected, right? Because I said, okay, we remove now the output that actually pays to the address 2, and then the smart contract should fail. And yeah, if you look here, we had this assertion, and then we have the error message insufficient reward sharing if in case it fails. And exactly this is what is printed here. So when the script is executed, it fails, and the error insufficient reward sharing is printed. Okay, and so now this line we previously commented out here that puts the output to this second user. We want to put it back. And then let's test again the withdrawal. So get the UTXO from user1 script address and put it here. And as we see, now the amount 1, so this is what is kind of amount 1 is what is fetched here, like the rewards available to this user1. So we see actually some rewards have been accumulated, right? This is not 0, so then this is what we want to withdraw, and then amount 2 is like kind of half of it, which is paid to the second user, and that's why the this time the script passes successfully, and the transaction goes through. Okay, so I hope now that we've basically seen the whole workflow from setting up the testnet to writing a simple smart contract in OpShin, to then building it and actually deploying and testing it in this testnet. I hope you get a bit of a feeling for how this works, and to practice a bit yourself. We will have a homework, and this I will show you in the next video.